Hi everyone. In today's video we're gonna take a look at the airline passenger dataset, which is a very common dataset for time series forecasting. And we're gonna try to make some predictions and then make some feature engineering and try to get results as close as possible to the actual data. Alright, so let's start from here. So we'll make a markdown cell talking about the airline passenger data. And we'll start with a few imports. So I have the dataset here in the airline passenger.txt. So we're going to use pandas. So I'll use import pandas as PD, and we'll import path or import from path lib import path. You see that I've got Copilot set up, which is such an awesome tool. Okay, now the name of the file is something like file name equals this, and then we'll do something like that. So we'll load the file name with the index column being the month and parse dates equal true. We'll see if that. Let's call this one passengers. And let's see if that works. Drum rolls. I'm not find error. Airline underscore passenger.txt. Okay, there's no S. Nope, still not. Right. Oh, sorry, it's a .text. Right. Okay, so there we go. So you see this is the data, and so this is the month basically between 1949 and 1960, and this is the number of passengers that we don't have much of an idea for now, but we'll plot it and we'll see it better. Okay, so this I'm doing inside of the notebook, but I guess most of the code I'll put it in a separate Python file. So I can just import it, and the notebook is not super long. Alright, what else do we want? We want to plot this, so we'll do we'll import a bunch of Plotly stuff, which is Plotly Express, Plotly Graph Objects, and Plotly.io. Plotly.io is to make the background white because I think it looks fancier. Alright, so we'll we'll plot this. So we'll do something like px dot lines, and then we'll take okay, let's just see if Copilot gets it right. Not quite. Okay, so let's make a figure, so something like fig equals go.figure, and then something like fig.addTrace, go.scatter. We'll take the index, which is the month here, and then we'll take the passengers. Maybe I'll just rename that column quickly. So something like passengers dot rename columns equals something like passengers. Yes. So okay, so we want it lowercase, right? Let's make the month column lowercase as well. Okay, sorry, that was a predefined one, I guess. So the reason it didn't work is because inside of the airline passenger, I guess we have month with a capital M, so that's why it didn't work. But I prefer having them lowercase. So let's just remove that for now and go with something like month, forgot quotes, month, there you go. Why didn't that work? Okay, I guess it's because it's the index column. So let's go with this, and then passengers dot index dot name equal month, and yeah, that works. Okay, cool. What else do we want? Let me check. So we'd like the. Okay, I did it a bit differently in my code, so let me import it. I think it's a bit better. So we'll go for that. Okay, so what are we doing? Okay, file path, whatever. File path is the name of the file, and we'll take date. We'll have names, these names for column names. The index call is going to be the date, which is also like a datetime object, which is what this parse dates means. And we'll load the passengers as a float so that pandas doesn't think it's categorical data. So let's try that again. Right, okay, there we go. So we have the date here, the passengers. We see that because of the .0, the passengers is loaded as a float. And most likely we can do something like passengers.index. That works, and then something like .month. And I guess, yeah, we should get the month, right? So this is because the first index has month 1, then 2, and 3, and so on. Right, so let's stick with that for now. Okay, we'll continue the plotting. So we want the x equals passengers dot index, indeed. Y equal passengers dot passengers. Let's put it in a column way, like this. I like it better. Right. Okay, so we've got that. So this is fine. But then what I'd like to do is to, so like plotting like that is fine, but what I'd like to do is to split it eventually. Maybe we can keep it like that. Fig.update layout, and we'll just take Copilot's suggestions, since they work fine. Do we want that? Sure. Okay, let's go with that. See if that works. Okay, there you go. So we're having the dates. So the data is starting from 1949 all the way to 1960. And you see that the number of passengers is increasing over time. Oops, sorry, maybe you can't see. So the number of passengers is increasing over time. And we see that maybe it's more like it's clear if I make it tighter, but we see that there is some repetition in the pattern, right? And you can tell actually that these months where the highest values are actually July and August, which makes sense, right? I guess more people go on holiday during July and August. All right, so first thing first, we'd like to split the data. So split into train. Let's go with train, validation, and test set, right? Okay, so here we'll start using the function we'll write here. So we'll do something like print hello. Oops, sorry. Print whatever hello, and we'll just make sure that we're able to import this thing. So import airline passengers as AP, and if that works, we should see printed hello right here. So let's do it. Okay, that works. Cool. So we'll remove that obviously in a second, but before that, what I like to do is to use the extension loadExt, like the extension auto reload, and then we'll auto reload too. So that basically means that whenever we make a change in this file and we save the file, it's gonna happen in the notebook, like it's gonna be reloaded, right? So we'll do that, we'll run that. And now in this file, we're gonna make a train validation test split, which is going to take something like a data frame, right? So data frame is going to be, let's go with type hinting. So pd data frame. What else do we want? Train size, which is going to be a float, and then test size, val size. Let's start with val size. Do I have Copilot on, or is it sleeping? Which is also going to be a float. Then we have test size. Size, which is also going to be a float, and something like shuffle probably, in case we want to shuffle, but in our case we likely won't. So this is going to be a bool, right? And okay, let's. I guess I haven't imported pandas. So import pandas as PD. Then what do we want? We want to close this, and I guess it's going to return. So I guess it's going to return like a tuple. Oh, okay, that works. That works, but I guess it's going to return a tuple with 3 pd.dataframes. Right. So let's go with that. Okay. Not sure I want all of that now. So let's start with splits the data frame. Yeah, that works for me. Okay, so we're gonna use the from sklearn. Yes, this one, and then we're gonna do something like okay, train-val. So we're gonna make the first data frame, which is train-val, and then another one which is test, and we're gonna train test split. So I don't like positional arguments, so I'm not gonna use the suggestion from Copilot, but oh, okay. Exceptionally, since the first argument is has this star here, I'll use it. Train size equals. Okay, do I want that? Let me check. Okay, so not quite yet. I'll just want to do one thing before, which is to compute the train-val size, which is going to be train size plus val size. Yeah, that's fine. And then, so my train, so this means like the first part of the indices is going to be train-val size. Shuffle equals shuffle, that seems about right. And then we're going to get train and a val, which is going to be train-val. Yes, train size equals, so the proportion of train size with respect to the train-val size, that's fine. And then shuffle equals shuffle. Cool. So now we have our train, val, and test sets, right? I guess they're data frames, but not sure. We'll return them, and I mean they should be data frames, but let's see. All right, let's format that. Okay, cool. This is a C-Black, by the way, so it's Control-Shift-I, and C-Black formats everything for me. So, so you see, I saved the file, and now everything should be loaded already. So I guess if I go into the cell below, oops, actually one more, and we want to do something like train validation test. Oh, sorry, AP. So AP is what we call the Airline Passenger module, I guess. AP.train-val-test. Yes, this suggestion is quite nice. df equals passengers train-val. Okay, so let's right. Let's figure out our train-val and test sizes. Right. Let's go with that. Train size. Do I want train size? Okay, so I could do that. I want the test size to be a third. equal 1/3, and something like val size equal, okay, so let's go with the 1 minus train size minus test size, right? And does that work? It's running. Shuffle is not defined. Oh yeah, obviously. Let's just go with false. I guess we don't need to have a variable for that. Right, so it seems like we got 1, 2, and 3 data frames, right? Okay, so let's assign those to train, val, and test datasets. And let's print, well, let's display train, right? Invalid syntax, oops, my bad. Okay, 86. So let's go with dot shape, and then val.shape, and then test.shape. Okay, so it seems let's go with passengers.shape as well. So the total size is 144, and we only have one column, which is the one with the passengers data. The one with the time is the index, so it's not counted as a column. So we have like 60% for train, 1 minus 60% minus a third. I guess that's that for validation, and this for test. What we'd like to do though is, like, if we don't specify one of the arguments, we'd like this function to figure out how much the last argument should be. So in this case, if I don't specify val size, I would actually like my function to understand that val size is 1 minus train size minus test size. So for that, I'm going to go here and I'm going to say, so I'm going to initialize my train size to none, I'm going to initialize my val size to none, and I'm going to initialize my test size to none, and shuffle. Okay, let's initialize it with false. The reason I'm initializing for shuffle is because positional argument, like I mean, if you don't have a default value, you can't be after a parameter that has default value. Right, so let's go with that. Why is test size not being used? Okay, I guess that's fine. But now we're going to use it. So let's go. Okay, let me copy this because it's not super interesting. So let me copy it from my source file. So that's what I want. So basically, we're checking if train size is none. If not, train size is none. So if train size has an argument, if val size has an argument and test size has an argument, then we check that the sum of the three equals 1. Otherwise, we print this message, right? And then if one of them is not passed as an argument, we'll define it as 1 minus the two others, right? So if train size is none and neither of the other ones is none, then train size is 1 minus val size minus test size. And then we'll do the same for these, right? And if like at least, like in the other case, if at least two values are none and they don't sum up to 3, I mean, if at least two values are none, then we just print a value error because this is unexpected behavior. Right, so here, I guess if we don't pass file size, we should have the same shapes. So let's see if that works. Let's run it. And we get the same shapes. Do I know that it actually updated the file? Well, let's print like an update message or file updated. Right, file updated, and now if we run it, we'll see that normally without rerunning the whole notebook, it should. There you go. So it actually updated the file, right? So from now on, we'll trust it. It's just in the beginning you want to make an effort to trust this this extension, but then we'll get used to it, and it helps us saving a lot of time. Right. Okay, so that's going to be for part 1, so I don't want to be too long. So we have the three like data sets. Do I have some? Let's go with something like I don't know, val size. Okay, in my notes I've wrote val size equals 0.1, which we can also do. We should also be able to pass val here, right? So val size, and not passing train size, but I guess it should work as well. Cool. Okay, so we've got validation, which is 15, which is about a tenth of the total size. So that works. Now let's make another plot with fig equals go.figure, and then we'll plot each of the indices. I guess that should do what we want. Okay, cool. Yeah, and then same with val, and then same with test. And we can update layout to make it prettier. X-axis title date, x-axis title passengers. Sure, let's format, and that's it. Right. So this is our train set. This is our validation set. This is our test set. So the thing I didn't explain for the for what these actually are, I mean, probably you know already, but the train set is the set, like the set on which we're going to train our algorithm. So it's going to learn how to perform on this set, and then we're going to evaluate it on the validation one, which it has never seen before. But in order to make sure that it doesn't learn, although you don't show it the validation set, we're going to eventually report metrics and like actually test our algorithm on the test set, because this one, like, it doesn't get a feedback. Like the validation set, the algorithm gets a feedback every time it gives an answer, and you tell it, okay, you performed this well on the validation set, and so you can like indirectly optimize for the validation set, although you don't see it. So what the point of having a train-val-test set instead is so that the algorithm has never been trained on the test set. It never got feedback from the test set, but then you just test it on the test set, and you report those metrics. Right. So cool. This is the split we're gonna use, I guess. And okay, let's move this to the file as well, to the Python file. So let's do something like actually it may come before, whatever. So let's do something like how did I call that in my file, just to be coherent? Plot train test split. Yeah, plot. Okay, let's call it plot train validation test split. And okay, is that very fine? Okay, let's give it train val test. No, we don't want target. And it's gonna return a go.figure. Go.figure. Come on. Yes. Plotted times the time. Okay, that's fine. So we need to import go. Let's go with that. So import plotly. There you go. And then we're gonna write a doc string, something like plot the train validation test split. That's fine, and then we're going to paste the content of our cell from just before. So there you go. Let me indent that properly and return fig. Okay, so does that work? Let's go with plot. Oh, sorry, ap dot plot. Just make sure you save the other file, otherwise it won't work. So let's go with train equals train-val equals val-test equals set test, and that works as expected, right? So cool. So we're gonna keep that. So what else can we do? Okay, should we stick with that for now? I guess we'll stick with that for now. So we'll just add a bunch of comments before pushing. I'll push it to a GitHub repo. You'll have all the code in the on GitHub. I'll put the link in the description, and yeah, then we'll close it. So this is, did I write train test split already? Yes, I did. So something like, let's plot our train validation and test sets to see how they compare. Yeah, that's cool. And so we split our data into train validation and test sets. The validation sets is used to tune the hyperparameters of the model, and the test set is used to evaluate the final model. Yep, that sounds cool. No, we don't want Python code. Okay, what else? Okay, let's load the data. Something like load data, or like introduction to data. The data set, and we load the data and plot the time series. Yeah, that's fine. Cool. We'll load the data and plot the time series. All right, so I guess that's it for this time. And next time we'll do more. We'll actually make the model. We'll tune hyperparameters. We'll define the sequence length. I'll talk about time series and all the good stuff. Right, so that's it for today. I mean, there hasn't been much content recently, but the next videos are hopefully going to come soon. So if you could like this video and subscribe, that'd be great. And you can also share it to someone who'd like to know about time series. All right, see you next time.